This is Shane Chu. I'm going to be teaching a lesson on sequences and series here. So we're starting here, Algebra 2. Sequence. Okay, a sequence is an ordered list of numbers. Each number in the sequence is a term of the sequence. Terms of a sequence are often arranged in a pattern represented by the letter A with a subscript as shown below, A of 1, A of 2, A of 3, etc. We're also going to be dealing with what's called an explicit formula. An explicit formula describes the nth term of a sequence using the number n. A finite sequence is a sequence with a first and a last term, A of 1, A of 2, A of 3, ending at some number. An infinite sequence is a sequence that continues without end. Plain English, what all of this means is I'm going to show you how we would find terms of a sequence, starting with these examples here. Number 1, write the first 6 terms of the sequence defined by the given explicit formula. A of n equals negative 2n plus 3. So we want to find the first 6 terms of the sequence. So A of 1 is going to be negative 2 times 1 plus 3. Negative 2 times 1 is simply negative 2 plus 3 will be 1. That's our first term of the sequence. A of 2 would be negative 2 times 2 plus 3. So that's negative 4 plus 3, negative 1. A of 3 will be negative 2 times 3 plus 3. So that will be negative 6 plus 3. That will give us negative 3. A of 4 is going to be negative 2 times 4 plus 3. That will give us negative 5. Now, A of 5 will be negative 2 times 5 plus 3. That's negative 10 plus 3. That will give us negative 7. And finally, A of 6 will be negative 6 times 2, negative 2 times 6 plus 3, negative 12 plus 3, negative 9. Those are the first 6 terms of our sequence if we're doing this by hand. Now that's how we would find them by hand. We can also use a calculator to find the same information. Let me show you how we would do this on calculator. We're just going to pull our calculator up here, turn it on. And come on, turn on here. Okay, there we go. So clear this. Second, quit. All right, so quit. Okay, clear this. Let's see here. Okay, let's just start this again here. I don't know why that's happening. We'll just start it again. That's no problem. So, we'll just start our calculator application again. And it's asking. Okay, let's see. Okay, we're going to quit. All right, let's clear this menu. All right, so now our calculator is clear. We're going to go to second, stat. We're going to write arrow over to ops. We're going to choose option 5 for sequence. The expression that we're dealing with is negative 2n plus 3, which we have here. So we're going to place that into our calculator. Negative 2, we're going to use the variable of x, plus 3. The variable that we're working with is x. Since we want the first 6 terms of the sequence, we're going to start at 1 and we're going to end at 6. So what we're telling the calculator is we want the first 6 terms of the sequence negative 2x plus 3 using the variable x. Now, when we hit enter through, now we have the terms 1, negative 1, negative 3, negative 5, negative 7, negative 9. Those are the same terms that we arrived at when we performed by hand. So whether you manually find them or use your calculator, you should receive the same answer either way. Okay, let's look at the next one here. So we have a of n equals 2n squared minus 1. We want to find the first 6 terms of the sequence. So a of n, or a of 1, would be 2 times 1 squared. 2 times 1 squared is just 2 minus 1, so that should be 1. A of 2 will be 2 times 2 squared. 2 times 2 squared is 4. 2 times 4 is 8 minus 1. That should be 7. A of 3 should be 2 times 3 squared. 3 squared is 9. 2 times 9 is 18 minus 1. Be 17. Now, a of 4 should be 2 times 4 squared. 4 squared is 16. 16 times 2 is 32 minus 1. That should give us 31. A of 5 should be 2 times 5 squared. 5 squared is 25 times 2 is 50 minus 1. That should give us 49. A of 6 should be 2 times 6 squared. 6 squared is 36 times 2 is 72. Minus 1 should be 71. Okay, so those are the numbers as determined by hand. Let's use our calculator, see if we arrive at those same numbers. So we're going to go back to our calculator. Let's clear this out here. Again, the steps we're going to take, we're going to hit the second key. We're going to hit stat. We're going to right arrow over to our ops and select option 5 for sequence. The sequence that we're going to place in is negative 2x, is 2x squared, x squared minus 1. 2x squared minus 1. And the variable is x, and again, we want the first 6 terms. So that's what we're going to enter into our calculator. If we press enter, we should get those same 6 terms on our calculator. What do we get here? So, we get 1, 7, 17, 31, 40, the same 6 terms that we acquired by hand. So again, whether on calculator, whether by hand, we can obtain any number in this sequence. And this just doesn't have to be the first 6 terms. We can look for the 3rd term to the 10th term. We can look for the 50th term to the 55th term. It does not matter as long as you know what terms you're looking for. Okay, let's look at C here. And let's try this one and let's see what we get. So we have A of n is equal to n times n minus 3. Well, let's find the first term of this sequence. So A of 1 is going to be 1 times 1 plus 3. Okay, so 1 plus 3 is 4 times 1, so that should be 4. A of 2 is going to be 2 times 2 plus 3. 2 plus 3 is 5 times 2, that should give us 10. A of 3 should be 3 times 3 plus 3. 3 plus 3 is 6 times 3, that should give us 18. A of 4 is equal to 4 times 4 plus 3. 4 plus 3 is 7 times 4. That should give us 28. A of 5 is going to give us 5 times 5 plus 3. 5 plus 3 is 8 times 5, that should be 40. A of 6 is going to be 6 times 6 plus 3. 6 plus 3 is 9 times 6. That should give us 54. Okay, so that's what we got by hand. Let's take a look by calculator. Let's see if we get those same answers. Okay, so we're going to clear our screen. Again, we're going to hit second, stat, right arrow over to ops, select option 5 for sequence. The sequence that we're using is going to be x times x plus 3. Again, our variable is x, and we're looking for the first 6 terms of the sequence. First 6 terms. And what do we get? Lo and behold, we get the same numbers either by calculator or by hand. Okay, so again, we can find any number in the sequence by using this formula. We can either work it out by hand, or we can just hit the second key, stat, ops, sequence, place in our sequence the numbers that we want, and we can obtain. Any questions with that? Okay, so we're going to move on to another problem here. So let's scroll down. Now we're going to talk about a series. Okay? A series is the indicated sum of the terms of the sequence. The summation notation uses the Greek letter sigma to express a series in abbreviated form. A finite series has a first term and a last term. An infinite series continues without end. Plain English, the difference between the series and the sum here, we're going to use the summation when we want to take all of the terms that are in the series, add them together, and find our total. This is when we're going to use summation notation. Let's look at an example to see how this is done. Example, the series 2 plus 4 plus 6 plus 8 plus 10 can be represented in a summation notation where n equals 1, that's our first term, and 5 is our fifth term, and our explicit formula is 2n. The sum of 2n for the values of n from 1 through 5. Now, if you go onto your TI-84 calculator, let's show you how this works. So, we're going to bring up our calculator. We're going to clear our screen. We're going to hit the math key. Under math, if we scroll down, option 0 should be summation notation. Option 0, summation. So now we're in our summation key. Now let me move this over because we want it to look just like what we have here on our screen. So we're going to place in x in this first box equals, let me go back over here, x equals 1, which means we want the first term. Then we're going to go back up to the top and we're going to place in 5. We want to go from the first term to the fifth term, and we want the summation of the formula 2x. So again, what this is saying on calculator, summation notation, I want you to give me the first term in the sequence through the fifth term and add them together and give me the total. When we hit enter, we're going to get a total of 30. Because if you add 2 plus 4 plus 6 plus 8 plus 10, that indeed equals 30. So let's look at these examples here, and let's see what we can get. So, first thing we're going to do, write the terms of the series and evaluate. So they're not only asking us for the terms of these sequences, they're asking us for the total as well. So, let's place in this sequence here for 2a. So I'm going to go to math. I'm going to select option 0 for my summation. Now the variable is x that we're always using, and we're going from 1, the first term, we're going to go up to 4, and the explicit formula that we're working on is 5x. Because in 2a, they're asking us, I want you to tell me the sum between the first term and the fourth term, working on the explicit formula 5x. So I need to place in the 4 up top here. Let me go back for that. And 4. Okay. So there's our formula. So now, it says that our total, our sum is 50. Well, let's find the terms of this sequence and see if it indeed comes out to be 50. Those are our terms. What we're going to use now, we're going to use the series formula to find the 4 terms of the sequence. So, in our calculator, if we go to second, we hit stat, we go to ops, option 5, sequence, which is what we did previously. Now, our explicit formula is this 5k, which we're going to enter in as 5x. The variable is x, and we want the first 4 terms. So that's why my start is 1 and my end is 4. So basically, we're telling me I want the terms of the sequence for the explicit formula 5x using the variable x, first 4 terms of the sequence. And if I hit enter, okay, so I get my 4 terms as 5, 10, 15, and 20. So if I write these terms, so these terms are 5, 10, 15, 20. And if indeed you add 5 plus 10 plus 15 plus 20, that indeed totals up to 50. Okay? Now, this first one we just did this one. The only difference between this one and this one is there's a number 4 in this formula here. What this is saying is, give me this formula, but I want the value 4 times what it is. So let's see how we would place this in. First, we're going to start with our terms. So, let's clear our screen. We're going to go to second, stat, ops, sequence. Now, we have 4 times 2x. So that's what we're going to put in. 4 times 2x. 2 of x is our formula, but it's being multiplied 4 times. Then, our variable always remains x. In this particular formula, they're asking us for the first 5 terms. So my start is 1, my end is 5. So, placing this in. So, the 5 terms I'm getting are 8, 16, 24, 32, and 40. So then we just need to, so let me go ahead and place these in. 8, 16, 24, 32, and 40. 24, 32, 40. If we add each of these numbers together, our total should come out to be 120. That's just simple arithmetic. But let's use the formula here and see if we get 120 as well. So we're going to go into our calculator. Again, we're going to go math, option 0 for summation. We're going to use x for our variable, 1 for our first term. We're going to go up to 5 because we want the 5th term. Now, with our explicit formula, it's 4 times 2n. So what I'm going to place in here is 4 parentheses 2 of x. Okay? And we see that our summation formula does give us 120, the same thing that this adds up to be. So again, whether we're doing this by hand Whether we're doing this by calculator, we should get the same answer either way. We'll do this last one here, and then we'll call it a wrap. So, let's go back to our screen here. This formula is telling us we want the third through the sixth. Notice it's not the first 6 terms. They only want the third through the 6th term working on this formula 1 plus k squared, which we'll place in as x. So let's find the third through 6th term for this particular formula. So we're going to go back to our calculator. We're going to clear our screen. We're going to hit second, stat, right arrow over to ops, 5 for sequence. Now, our formula is going to be 1 plus x squared. Our variable is always x, but our start is going to be 3, and our end is going to be 6, because they're only asking us for the third through 6th terms of this particular formula. So, the third through 6th terms for this particular formula happen to be 10, 17, 26, and 37. So let's put those in. 10, 17, 26, 37. Now, we can simply just sum those up. Let's just add those up really quick here. 10 plus 17 plus 26 plus 37, and that equals 90. Let's use our summation formula and see if this equals 90. So let's go back to our math. Option 0 for our summation. Our variable is x. Our first number is 3 because we only want the third through the 6th terms of this sequence. We're going to go up and we're going to put 6 here. Our explicit formula is going to be 1 plus x squared. So I'm going to plus 1 plus x squared. So to place that in, lo and behold, we get 90 as well. Move this over, get 90. So, as you can see with an arithmetic series, we can either work them by hand and obtain our number, or we can use our calculator to obtain our number. And it doesn't matter if we're looking for the first 6 terms, the first 10 terms, the third or the 6th terms, whatever number of terms, we should easily be able to identify what the terms are for a sequence. Any question? Okay, I'm going to leave you there. Work on the rest on your own.